Okay, so today we will discuss the Norton equivalent. So far we studied the Thevenin equivalent circuit. So these two are interrelated. We can transform the Norton, we can get the Norton equivalent circuit from the Thevenin equivalent circuit. For example, if we have some circuit and we got this Thevenin equivalent, that VTH is the Thevenin voltage and RTH is the Thevenin resistance. So this can be transformed into a current source in parallel with resistance. You see here, this is voltage source in parallel with the resistance, in series with the resistance, sorry. So this can be easily transformed into a current source and in parallel with the resistance. So that current source is referred to as Norton current source, and we can denote that by IN. And similarly, the parallel resistance is equal to the Norton resistance, and that can be represented by Rn, just to distinguish from the Thevenin resistance and the Thevenin voltage. So in order to get the equivalent Norton resistance from a complex circuit, so we are doing a series of source transformation. For example, just look at this figure. We have a voltage source, 25 volt, 5 ohm resistance, 20 ohm resistance, 3 ampere current source, and 4 ohm resistance. Simply transform this portion of the voltage and resistance into a current source and resistance. So just to get the current from this combination, so 25 divided by 5 is equal to 5. So current source will be equal to 5 ampere, and this resistance will be connected in parallel with the current source. So we have just made the source transformation in this portion of the circuit. The rest we left as it is. A 20 ohm resistance is there, 3 ohm and 4 ohm resistance is there. Okay. From here, this current source and this current source, they have the same direction, similar direction. So these two current sources can be added up because linear circuit. So all the current sources can be added. So 5 ampere and 3 ampere current source, it will result into 8 ampere. And what about these two resistances? These resistances are in parallel. So just if you want to compute the equivalent resistance for this parallel combination, so you will have the equivalent resistance is equal to 5 into 20 divided by 5 plus 20, which is equal to 4 ohm. So you will have 4 ohm resistance here, and 4 ohm resistance is already there. So you have now 8 ampere current source, because 5 plus 3, 8 ampere, and 4 ohm resistance and 4 ohm resistance. So now again we will do the source transformation, and this 8 ohm multiplied by 8 ampere multiplied by 4 ohm, it will result into a voltage source which is equal to 32 volt, and 4 ohm plus 4 ohm resistance, it will result into 8 ohm resistance. Now we have something transformed into an equivalent voltage and series resistance combination. So this is the Thevenin voltage and this is the Thevenin resistance. So we will again do the source transformation exactly in similar manner. So just dividing this voltage by this resistance, so we will have 32 by 8, 4 ampere current source, and this 8 ampere will appear in parallel. So now this is the Norton equivalent source and Norton equivalent circuit of this whole circuit, and this is the Thevenin equivalent representation of this whole electrical circuits. So this is the way how to get the Norton equivalent circuit from a complex electrical circuits. So just we will have to do series of source combination, and finally we will get that. You can use the node voltage method. You can use other methods which we have discussed in our previous lectures to get the Thevenin equivalent representation of that circuit, and after that, just one step after that, you can get the Norton equivalent circuit. So this is very simple, not very difficult. These are the two equivalent representations. One is the voltage and series resistance representation, and another is the current source in parallel with the resistance representation of the circuit.